Example number 2. In this case, you have what are called two binomials being multiplied together. So these are specific types of polynomials that contain two terms. Many of you probably learned how to do this using FOIL, which is great. That's fantastic. What you're really doing when you use FOIL is you're using the distributive property. So let's go ahead and talk about that. You got 2x distributed through this first term. Because aren't you really doing 2x times this quantity? And then you're going to do 5 times this quantity as well. So let's see how that works out with FOIL. So what's FOIL? F-O-I-L, right? So the first part of FOIL would be 2x times 3x. 2x times 3x would be 6x squared. That's the first part of FOIL. And then we have the outside part. So the outside part, right here, would be the outermost terms here, the outermost terms. So 2x times negative 1. Well, 2x times negative 1 is negative 2x. So now we're finished distributing, really, the 2x through the quantity of 3x minus 1. And we've completed half of the FOIL process. Let's finish the FOIL process now. Now we move to the plus 5. So plus 5 is now being distributed through, again, this binomial. So this is the I part of the word FOIL, okay? If you can see that there. The innermost terms are now being multiplied together. So 5 times 3x is what? 15x. And then the last part of FOIL, right here, would be the 5 times the negative 1, okay? The two last terms in each of the two binomials are being multiplied together. So that's given us what? A negative 5. And now at this point, if you can combine any like terms, then definitely do so. And we have a pair of like terms right here. So your final answer would be what? 6x squared plus combined, right? They're like terms. They both are x's. Negative 2 plus 15 is 13. 13x. And then bring down the minus 5. And we're finished with example number 2. All right, let's look at example number 3. In example number 3, a couple different things going on here. In the first part of this, you have a binomial squared. Do we all remember what to do if you have a binomial squared? Well, let's see. I'm gonna write down this 3x plus 2 squared over here. What this means is what? We talked about it at the very beginning. If you have a base to the nth power, your n is 2 this time, that means you're going to write this base down that many times. So it literally means 3x plus 2, that quantity, times the quantity of 3x plus 2. And then you could FOIL this again. So 3x times 3x is 9x squared. Outside would be plus 6x. Inside would also be plus 6x. And last would be 4. Now, combining like terms, you would get 9x squared plus 12x plus 4. So just this first part means what I did over here, okay? All right, so I'm going to go ahead and bring that down. So we know the first part is 9x squared plus 12x plus 4. Okay? There's a formula for this as well. But, if you forget the formula or not a big formula person, which is fine with me, you can always just work it out. It doesn't take that long. And it's good practice to go through that FOIL process anyway. Okay, so we are now going to use the distributive property, at this point specifically, because we have a single term preceding the quantity of 2 or more terms. And so the quantity in this case is 1 minus x. All right, so let's use the distributive property. So negative 2x times 1 is minus 2x. Now, what's negative 2x times a negative x? What's a negative times a negative? It's a positive. Negative 2x times negative x is a positive what? 2x. When you multiply like bases, you add their exponents, understood 1, plus an understood 1 right here and right there gives you a deuce. Bring down the minus 4. Now, are we finished? No. You always want to simplify all of your expressions if possible. Okay, so is it possible to do so here? Well, absolutely. You have 9x squared, 2x squared. You got a 12x, you got a negative 2x. I'm locating pairs of like terms. You also have a pair of constant terms. All right, so let's rock and roll here. 9x squared plus 2x squared, that's 11x squared. Finish with that. You have 12x minus 2x, that's plus 10x. Finish with that. And then 4 minus 4, that's 0. So finished. Okay, the last thing we want to look at in section 1-2 would be order of operations. PEMDAS. You might have learned it as please excuse my dear Aunt Sally. This just means parentheses or grouping symbols go first, then exponents, then multiplication and division as they occur from left to right, and then addition and subtraction also as they occur from left to right. Grouping symbols normally are removed in this fashion. Okay, so let's look at our final example from section 1.2. What you want to do in this type of problem is work from inside out. This is going to take us several steps. So you just want to be patient, take your time, and I would highly recommend you just do one thing at a time. So the first thing I'm going to do is, again, the most interior here. Work within the most interior of this expression. So I'm seeing a negative times the quantity of x minus 5. I'm going to distribute this negative through this quantity. So everything else is going to remain exactly the same. I highly recommend you do it the same way I'm doing this to help avoid mistakes. You try to do too many things at once, you're probably gonna skip some step, and it's gonna lead to a mistake. You're probably gonna violate the order of operations in some way, shape, or form. So don't do that, just take your time. All right, so I've rewritten everything exactly the same way as it was written initially. Now what I'm gonna do is distribute this negative through this quantity. So you get a negative x. What's a negative times a negative? Positive, positive 5. Okay? Note the parentheses are now gone. Okay, but everything else is the same. Now what I'm gonna do is, if possible, within the most interior portion of this, in other words, inside of the brackets, I'm going to try to combine like terms if possible. And yes, it's possible to do that. 2x minus x. So, everything else is staying the same. Inside the brackets, we get what? 2x minus x, which is x. Bring down the plus 5. And then also bring down the plus 4, close braces. These are called braces, by the way. These are called brackets. These are called parentheses. Okay, let's continue. All right, at this point, what do we do? Well, I see this negative 3 hanging out in front of the bracket. So let's go ahead and distribute this negative 3 through the quantity of x plus 5. And that would give us this next step. Right? Everything else stays the same. But here you got a negative 3 times x, it's negative 3x. Then negative 3 times a positive 5 is negative 15. Again, bring down what you did not work with. Keep it exactly the same. Okay, so now inside of these braces, can we simplify? Can we combine like terms? Well, sure. So let's go ahead and do that. This part stays the same. Now let's combine like terms. X minus 3x. That is a negative 2x. 1 minus 3, negative 2x. Okay. Negative 15 plus 4. Negative 15 plus 4 is negative 11. Close braces. All right. What do we do now? Well, here again we have a numerical value preceding grouping symbols. Okay, we have a negative 2 times, in other words, the quantity of something. And that something is negative 2x minus 11. So we are going to distribute the negative 2 through the negative 2x, giving us plus 4x, negative 2 times negative 2x, plus 4x. And then finally, negative 2 times a negative 11 plus double deuce, 22. Are we finished? No, because you still have a pair of like terms. 3x and 4x combine to give us 7 x's. Bring your 22 down, and the final answer is 7x plus 22. Finished with section 1-2. Have a good day.